Hi friends, in this video I'll be talking about what problem on permutation. Now let's consider the first question I'm having here. The question says, in how many ways can 5 students sit next to each other in a row? Now what we actually need to understand is that as far as permutation is concerned, permutation is a number of ways of arrangement of a particular items, or we simply say permutation is a number of ways through which an object can be arranged. Now, in this case, we have 5 students here, which indicates the object. Then, how can we arrange them in such a way that they are going to sit next to each other? Now, since we are having it to be 5 students, right? We have it to be what? To 5 students, right? Which is 5 students. Now, what will happen here is that if we have 5 students sitting next to each other, that means we are going to have 5 students sitting next to each other in 5 ways. Exactly. So it shows us if this is 5, then we can have it to simply to be, we can have it to be what? We can have it to be, let's say number of students is equal to 5, right? Then our R also will be equal to what? 5. That is the number of ways through which they can sit next to each other. Now, first, what I'm going to use is that I'm going to record the formula of permutation, right? So, recording the formula of permutation, I know that whenever I have n permutation r, that's equivalent to n factorial divided by what? N minus r factorial, right? And this is simply 5 factorial divided by what? 5 minus 5 factorial, which is equals to 5 factorial divided by what? That's actually 0 factorial. And we all know that whenever we have 0 factorial is written as what? As 1. Exactly. So here we are going to have to what? The overall answer to be 5 factorial. Then what is 5 factorial? 5 factorial is simply 5 multiplied by 4, multiplied by 3, multiplied by 2, then multiplied by 1. Right? So now this will give us the number of ways through which the students can actually sit next to each other. Now 5 multiplied by 4, that's 20, multiplied by 3, that should give us 60, then by 2, that's actually 120 ways. So it shows that the students can actually sit next to each other in 120 ways. So now the second question I'm having here says, in how many ways can first, second, third, and fourth prizes be awarded in a class of 15? The question is very simple, but first thing is that let's say we have 15 students, right? Let's say, let me just represent them as circle, right? This is my circle 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right? So I have 15 students. Then after that, I have how many prizes? I'm having 4 prizes. Let me just represent my prizes as what? As just, let me just put it as a triangle. These are my prizes, another prizes, another prizes. Now, the simple and the most efficient way of solving this question is that the question is, in how many ways can first, second, third, and fourth prize be awarded in a class of 15? Now, let's say, suppose I am having this first, second, third, and fourth prizes. Then I'm having 15 students. It shows as the first prizes can be awarded to any of the students. And all the students are actually what? 15. That means my first prizes can be awarded to 15 students. It can be awarded to 15 students. Then what of the second prizes? If first prizes is awarded to 15 students, we are going to have one cancelling out because we are left with 14 students because we've already awarded one of the students the first prizes. Now the second prizes can be awarded in how many ways? How many students do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are actually 14 students. That means the second prize can be awarded in what? In 14 ways. Now, what of the third? The third prizes can be awarded. This we cancel out in what? In how many ways? 1, 2, 3, 4, 5, 6. That's 13 exactly. Then what of the fourth prizes? The first prizes can be awarded in how many ways? That's actually what? That's actually 12. Exactly. 12 way. Right? So we can now simply say 15 multiplied by 14 multiplied by what? 13 and multiplied by what? 12 equals to what? We multiply everything here together. So multiplying everything here together, that's going to give us 3 32760 exactly. Now let's say we don't want to use this method and we want to use another method. So let's say, suppose here we have our number of students. What number of students is actually 15, right? And our prices is actually what 4, right? So you can just simply say this is actually 5 factorial divided by what 5 minus what 4 factorial, 15 rather, 15 minus 4 factorial, 15 factorial exactly, which is equal to 15 factorial divided by what? That's actually 11 factorial. Can you see this now? So my 15 factorial I can actually write it as what? As 15, right? Multiply by 14, multiply by 13, multiply by 12, multiply by what? 11 factorial divided by what? 11 factorial. So this cancel this out. Then I'm left with what? 15 multiply by what? 14 multiply by 13 multiply by 12, which is simply what? That's actually 32760. Can you see this now? So it's very simple. The answers are what? Are the same. So let's check the third question that we have here. The question says find the total numbers of possible permutations, that is of arrangement of the letter of the word chalk. So the chalk here is actually CHALK, right? So we can actually go with the simplest method by saying, okay, this is C, then we'll put here we have H, right? Then we'll put here, we simply put here again, we have, let's say we have CH, we have A, we have L, and also what? We have K. That's the first one. Then the second one, let's say we have H, then we have C, followed by A, followed by L, followed by K. Exactly. The next one, we have A, right? And let's say we go with, that's H, or let me just say we go with H, we go with C, we go with L, and we go with what? K. That's another arrangement. Then what other arrangement can we have? We have L. L come first. When L come first, followed by, let's say we have C, followed by H, right? Then followed by that's A, followed by what? By K. Exactly. That's another arrangement. Then when K comes first, we have it because that's actually C, H, right? Then we have A and L. Now listen, it's very simple. Now let's simply count all this. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5. That means we have how many numbers? We actually have 5 numbers of ways through which we can arrange all this number. But that's not exactly, that's not the answer. Now, we have how many words, how many letters that are present in the word chalk? We have 1, 2, 3, 4, 5. It shows as our n is equal to what? 5. And if we actually want to arrange it initially, the first arrangement is going to what? Be in 5 numbers of what? Of ways, which you can see now, as you can see here. That means in this case, our n equals to 5 and our r also will be seen as what? As 5. So now in this case, you can simply use the formula, right? So here we are going to have what? 5 factorial, right? Divided by what? 5 minus 5 factorial, exactly. So here in this case, I'm going to have what? 5 factorial divided by what? That's actually 0 factorial, which is 5 multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1, which is what? That's 120. So guys, the last question I'm having here with me was that the question says find the total number of different arrangements using any 4 letters of the word chapter. So it's very simple, but what you actually need to consider here is that they are not the question did not tells us that we should use all the numbers that are present in the word chapter, but we just have to use 4 out of it, right? And we using 4 out of it, that means we are left with 3 that we are not going to touch. If we touch the 3 with 1, that's another 4. We are not going to touch the other 3. So what we are going to do in this case is that this question is actually straight and direct. So find the total number of different arrangements using any 4. Any 4 means our R in this case is actually what? 4 letters of the word chapter. Then how many words do we have in how many letters do we have in the word chapter? We have 1, 2, 3, 4, 5, 6, 7. That's actually 7. That means our number of letters is actually 7. So you can simply use n factorial divided by what? N minus r factorial, which is 7 factorial divided by what? 7 minus 4 factorial, right? Which is 7 factorial divided by what? 3 factorial. This simply 7 multiplied by 4. No. 7 multiplied by 6, multiplied by 5, multiplied by 4, multiplied by 3 factorial divided by 3 factorial, right? This cancel this, then we are left with 7 multiplied by 6 multiplied by 5 and 4, which is actually equals to that's 840, if I'm not wrong. That's actually 840. So that's the end of the video under word problem on the permutation. My next video will just be cyclic permutation and also repetitions of permutation with repetitions rather. So if you enjoyed this video, please kindly click on the subscription button and do well to share my video with your friends, and don't forget to click on the notification button as well. Thanks for watching.